Good morning, students. In the previous class we completed a reflection or refraction in the lenses and at the plane surfaces, real depth, apparent depth. But next is prism. Few points only I will discuss prism and then we'll work out the problems. Prism is a transparent material with two transparent surfaces where the refraction is taking place separated by some angle. This A is called as angle of the prism. It is also called as a refracting angle. You have to be careful with the word. Angle of refraction is different from refracting angle. See A, B, C. It is a cross section of the prism. Prism need not be having the triangular cross section. It can take a rectangular cross section also. Rectangle glass slab if you have taken this corner. If the light is falling here and coming out from this side, these two surfaces are called as refracting surfaces. Here this AB, AC can be reflecting surfaces. That means if you take normal to this A and B, the light is falling on the surface. This is called an incident ray. The angle between the normal and incident ray is called as the angle of incidence. PQ is the incident ray. And afterwards it deviates in going into the denser medium glass, for example. It deviates toward the normal. This is normal, so bends toward the normal. And again you take the normal to surface, other surface. And here going from denser medium to radiant medium deviates away from the normal. Trying to go this side actually, but it deviates away from the normal. The result is prism always bends light rays towards its BC. BC is called as the base of the prism. Refraction is taking place on the surface AB and AC. These are called as refracting surfaces. The angle of the refracting surface is nothing but called as the angle of the prism or refracting angle. If you take this rectangular surface, if the light is falling here at some angle and refracts towards this and here falls, light always travels in a straight line path, you have to remember, unless the density, optical density gradually changes. Here falling here goes coming out like this. This angle between the two refracting surfaces is called as the angle of refraction. So this prism need not be triangular shape, it can be rectangular, it can be hexagonal, it can be any shape. They should have a corner angle separation between the two transparent surfaces, and that refraction is not taken on the surface, that is called as a base of the prism. Is called as a base. And in this case the angle of incidence is say I1 I will take, or I we can take. It is going into the prism, deviating away from the towards the normal. So this is called as the angle of refraction. Light ray path is reversible. Okay, if a light comes here, it will go in the same direction, retrace the path. Here after falling onto the second surface, this is supposed to be the angle of incidence on the second surface. Then this is going to be angle of refraction on the second surface, for the second surface. This normal is N1, normal is N2. Light ray path is reversible, so for comfort purpose only, this is, if this is angle of incidence, this is going to be angle of refraction. So what are the angles of the inside, that is taken as an angle of refractions only. And whatever this light is coming out angle with respect to normal, this angle is called as a angle of emergence, I2 or E we can take. The relation between this angle of the prism and refracting angles inside is nothing but equal to A is equals to R1 plus R2. Angle of prism A is equals to R1 plus R2. And the deviation, what is the deviation is, light instead of going straight, it is bending by some angle, deviating from the initial directions. This is called the angle of deviation. So this is going to be the angle of deviation of D1. But afterwards what happening is finally it is falling here, second surface. Again it has to go straight, but it is deviating by some other angle. So what is that angle? It is suppose it is deviating is nothing but equal to outside opposite angles. We can take it as a D2. This supposed to go inside, it goes straight in this direction but deviating by this angle, and this light ray, if it is going in this direction, deviating by reverse path of the light ray. If you have taken light ray is coming like this, supposed to go straight but deviate in this direction, so this is going to be D2. Then sum of these two angles is supposed to be external angle, internal sum of the internal opposite angle equal to external angle D. That D is called as the deviation. The total deviation D is nothing but equal to D1 plus D2. D1 plus D2. What is D1 is, light is traveling from radial to denser, so D1 is nothing but equal to I1 minus R1. D2 is nothing but equal to I2 minus R2. So the substitution of these values, what we get the relation for the deviation, total deviation is becomes equal to I1 plus I2 minus R1 minus R2. But R1 plus R2 is A, so this is the relation you need to remember for the numericals. But a special case is there. What happens if the angle of incidence continuously increased? Light ray falling like this, but I am making the light ray fall like this. Different angles I take. So what about the angle inside is the deviation light rays goes on changing its positions such that as the angle is increased for the incident rays, the refracted ray or final emergent ray it first decreases angle of deviation, means it goes like this. Instead of coming out here is increased, it comes like this, increased, it comes like this. So in the different directions it comes with the different d values. D values goes on decreasing if I is increasing. The plotting graph here, as I increases, the deviation value first decreases and then increases. As I increases continuously, deviation values first decrease and it won't become 0. Decrease from value and again increases. What is the value decreased up to this is called as the minimum deviation. Thereafter no more decreasing. That is called the lowest value of the deviation and taken as a dm, capital DM or small dm we can take. Whenever the deviation is minimum, what happened to the ray inside? Whenever the deviation is minimum in the prism, lowest values, then this I1 is equals to I2, and light ray inside the prism will be parallel to the base provided it is a symmetrical prism. Symmetrical means all sides equivalence. For example, equilateral prism, if you have taken 60, 60, 60. For that, light ray path is the minimum length inside the prism, minimum length point, remember, and also parallel to the base. If the light ray is not horizontal, it go up or it go down, the length will be more only. So minimum deviation condition, we have to take the application to the prism most of the cases in the experiments. So whenever the deviation is minimum, I1 is equals to I2, and symmetrically R1 equal to R2, light ray path is parallel to the base of the prism. These points you need to remember for the minimum deviation condition. Whenever the D becomes equal to D1, I1 equal to I2, R1 equal to R2. So you can take it as R1 equal to R2 equal to R, I1 equal to I2 equal to I. Putting the values into this deviation, D equal to DM, you will get a DM is equals to 2I minus A. A becomes equal to R plus R is 2R. These are DM values. Okay. And refractive index formula from Snell's law, if you take sin A by sin R equal to N2 by N1. One is a glass, this is N glass, this is air. You have taken air value is 1. So what you get the N glass formula you will be getting from these derivations for the prism material. N glass equal to sine of A plus dm, minimum deviation by 2 by whole divided by sine of A by 2. If it is equilateral prism, A equal to 60. This is 60 by 2 equal to sine 30. Sine 30 equal to half you will get. Most of the problems will be given for the equilateral prism or 90 degrees prism, called as orthogonal prisms. Next is A equal to 60 means this 60. So R becomes equal to 60 by 2. Means R becomes equal to 30 degrees for the equilateral prism. And right angle prisms. If you take the right angle prism, this is the right angle prism. Right angle prism, isosceles triangle, it's called as a orthogonal triangle, also it's called as a Poro prism. Poro prism is also right angle prism. One angle is 90, other are symmetrical, so 45 degrees. This is called as right angle prism. Applications of the right angle prism later we'll discuss. Now just to have some idea of this prisms, when light is light is passed through this prism, it deviates into disperses into different colors because the refractive index changes with the wavelength. So more refractive index, more deviation. For this deviation changes, if you take the small angle of the prism, small angle of the prism is less than 10 degrees, is called a small angle prism. For that case, I1 and I2, I1, I2, R1, R2 are very small angles. For that case, sin A by sin R, whatever is there, the formula you have to modify that as, instead of sin A becomes equal to I, sin R becomes equal to R, I by R it becomes. Remaining formula is applicable as it is. When you send white light into the prism, it splits into different colors because the refractive index changes with the wavelength given by the Cauchy's formula. CAU-CHY. Cauchy's formula, refractive index is nothing but equal to A constant by B plus lambda square plus C by lambda to the power of 4 and so onwards. Already we know this relation with the velocity changing with the wavelength and also lambda changing with the refractive index. Sorry, 1 minute. Refractive index, velocity, reverse related. So as the wavelengths. Here the Cauchy did the experiment. From the experiment relation, refractive index N is inversely related with the lambdas. So as lambda increases, frequency decreases. When lambda increases means refractive index decreases, so frequency decreases. That means if you take the red, lambda red is more than lambda blue or violet. Lambda is more means refractive index is less. So red color light has less refractive index than that of blue light. So in the VIBGR towards the red, refractive index decreases. Whenever the refractive index is inversely related to the velocities, therefore the velocity of the red is more than velocity of the blue. Red light travel with the more velocity than the blue light. Okay, here refractive index is related with the wavelengths. Therefore here white light, if you have taken, it has a different colors mixing is equals to white light, all 7 colors mixing, mainly primary colors. Primary colors are RGB, red, green, blue. Red, blue, green. this equal proportion, if you mix up, you will get the white. Or mixing the different proportion, you get the million colors of combination possible, but generally we take is white light coming from the sun, we take the 7 colors that we call as a WebGR. So white light passing through the prism, it has a different deviation values. What is the formula for the deviation given for the small prisms? From this simplicity we take a into n minus 1. A is the angular prism fixed, n is the refractive index. As n increases, the deviation also increases. This d1, d2 both increases. The result is you will get the light deviated by the different angles from violet to red. Red is deviated minimum and violet is deviated maximum. Why? Because more refractive index, more deviation. Violet has a blue or violet has more refractive index, therefore more deviation for that. So deviation means from initial direction bending by the large amount. So violet deviates more and red deviates minimum. We will get the spectra as WebGR in between. From here violet to red. Next is this angle of the prism. You see this dispersion is not in your syllabus for the CET and also theory exams, but it is there for the other competitive exams. I wrote only here, I didn't mention the CET. Now it is this whatever discussing is applicable for all the exams, please. CET, NEET and also JEE. Theory points, but in that I will tell you which is not included for what examination. This dispersion is not there for the CET. CET means CET. This CET applicable for all actually, and what I am discussing is applicable for all the CET exams. So CET only, this dispersion is not there, prism is there. But still dispersion I will discuss again at the end. Later I will skip those points now. For the prism and lens total interreflection, we need to work out some problems. Problems 1. Object size is 2 centimeters. Is placed 10 centimeter in front of the concave mirror of radius of curvature 40 centimeters. Then image size is how much? Here you are given object size HO is 2 centimeter, that is object size. HI is how much? That is image size. It is a concave mirror. Object you have to check up first. It is for concave mirror. Concave mirror, convex lens image formation is similar. Similarly, convex mirror and concave lens image formation is similar. And object distance is 10 centimeters. U equal to minus 10 centimeter, that is object distance. It is a concave mirror. Okay. Focal length is mentioned. Radius of curvature is mentioned. Radius of curvature is 40 centimeters. That is radius of curvature. So for the concave mirror, if they not mention what direction light is passing, we have to take the light is passing from left to right side. So we are keeping some object somewhere, and focal length we need to check up. What is the focal length and radius of curvature relation is R equal to 2f. R equal to 2f. F is equals to R by 2, which is 40 by 2, which is minus 20 centimeters. Minus simply indicates from the mirror left side. Center of the mirror we take it left side. So center point is pole. Take it as origin, and left side distance here. Focal length is 20 centimeters, but object distance is 10 centimeters. Left side, minus and minus, both minus only. So object is focal length is here, means this is a focus, but object is within the focus only. Both are minus, means left side only to take it. This is the object size. If you take the object left side, what happened to the type of image formed? Image formed will be virtual. Up to focus only will get the real images. The object is within the focus, means you will get the, this is a pole we take, this is an object. you will get virtual images formed behind the mirrors. So if you take the light ray passing like this to the focus, it should become parallel. Leaving this is going to be the image. Virtual image, it is virtual and bigger ones behind the mirror. But right side means you have to get the image distance as positive. This is going to be U. That we check up here. Then I will draw the ray diagram for that. Formula we have for this concave mirrors. Concave mirror focal length is negative. So F is negative. We have taken for this answer. Concave mirror. F we got is equals to minus 20 centimeters. And U equal to minus 10 centimeters. V equal to how much? And height of the image equal to how much? Okay. What is the relation we have for this mirrors? Spherical mirrors formula is this. Magnification equal to HI by HO equal to V by U. This relation, right side part is sufficient for us. Sorry, minus we have to put here. Minus V by U. Height magnification. M equal to height of the image by height of the object is equals to V by U. And 1 by F is equals to, first we have to find, we are given height of the object and U. V not given, image not given. So we can directly we can take 1 by F equal to 1 by V plus 1 by V, multiply into this throughout with U, like that you can do, or we calculate separately focal length. 1 by U plus 1 by V. V we have to find out. 1 by V equal to 1 by F minus 1 by U, which is equals to 1 by F is equals to, F is minus 20 minus U is minus 10. You can put the substitution in the first formula itself, that is left to your choice. This is minus 1 by 20 plus 1 by 10. Minus 1 by 20 plus 1 by 10. LCM if you take, it will be 200. I will just take 20 minus 1 plus 2, which is equals to 1 by 20. That means you got the value V equal to plus 20 centimeters. Plus 20 centimeters means positive one. Positive means what? It's supposed to be behind the mirror. Behind the mirror, and it's supposed to be virtual images. Because light cannot pass through the mirror. Mirror virtual. And whenever the V is more than U by magnitude, plus minus only indicates erected or image, erected or inverted. So V value, magnitude value 20, it is a 10. This V is more than U means image size is bigger size you have to get. Behind the mirror, virtual and erected. What is the formula for the magnification is equals to? Is equals to height of the image by height of the object is equals to minus V by U is the formula we have. Substitute the values into this. You have to calculate the height of the image. Height of the image by height of the object is 2 centimeters. It is positive only. Initially, you are keeping the object upwards means positive. This is height of the image. This is the height of the object. Sorry, this is height of the object. This is height of the image. Height of the image by 2 centimeters is equals to V. V is 20 centimeters. Here we got 20. But minus is there not from this relation. Here from the basic formula minus by U. U is minus 10. Calculate this. So height of the image becomes equal to 2 into 2, 4 centimeters. Positive. Positive means you will get a erected image. Negative means inverted image you have to take. You don't have to take so many steps for this. You don't have to take so many steps from the formula itself, question itself. You write the values there, symbols near that values, and focal length calculation. This formula not compulsory to do both together. You can also take the relation from this 1 by F equal to 1 by U plus 1 by V. Direct formula is there. You will be given, say, you will find the synopsis. Multiply throughout with U. That means U by F equal to u by u is 1 plus 1 plus u by v. So from this you will get a substitution directly, and u by v you can put into this relationship. You will get the expression required for height of the image. In terms of u, direct formula is there. You can remember that. You are not compulsory to remember many formulas. You can substitute and calculate if you can do little faster. Next, second question is, a person stands, this is not a problem, so directly can do workout. Person stands a distance 2 meters from the plane mirror. Person is standing in front of the plane mirror at distance equal to 2 meters. So what is the distance of the image is the question. Image distance equal to object distance. So this image is also at 2 meters, provided it is a plane mirror. Focal length of the plane mirror is infinity. Next, third question. Concave mirror. For concave mirrors, this is a concave mirror. Focal length must be left side. Left side means it becomes negative. Convex mirror, focal length is positive, fixed ones. Real image has a magnification. Real image told magnification m equal to 3. Object distance is u is equals to, but real image they told, given magnification works as a 3, but real images are supposed to be inverted images unless it is a form just now we discussed now, unless it is behind the mirror virtual image, then only you will get the that virtual image magnification is more than possible is there, and real images are always inverted images. So real image means supposed to be inverted. Whenever you take the inverted images, magnification must be -3. They may not mention minus sign in words while mentioning it, but equal to symbol if you are taking this equation means you must mention plus or minus. Object distance is u is equals to 10 centimeters they told, means minus 10 centimeters, and find the image distance v equal to how much they asked. So real image means it is supposed to be inverted image. Inverted image means m equal to -3. What is the relation between magnification u and v? Is m is equals to v by u with negative sign. Answer is m equal to minus v by u. What is the magnification is -3 is equals to v we have to find out. Minus v by u is -10. So v equal to, this minus into minus becomes equal to plus, v equal to minus 30 centimeters. Minus 30 in the sense it is a left side formed. U is here, v is here. Next is for convex mirror, focal length is 20 centimeters. Next problem is for convex mirror. Focal length is right side virtual ones. So object you are putting here, u here. V compulsory you will get a positive only. Fourth one, convex mirror focal length is 20 centimeters. F is equals to plus 20 centimeters. Object distance is 10 centimeters. So this is supposed to be minus 10 centimeters. Negative sign. U equal to minus 10 centimeters. Find the image distance. V equal to how much? Image distance, this is the object distance. What is the relation we have is 1 by f is equals to 1 by u plus 1 by v. magnification is not related. So 1 by f equal to 1 by u plus 1 by v we have, and u is given, f is given, v we have to find out. F is 20, 1 by v is equals to 1 by f minus 1 by u. V equal to 1 by f is 20 centimeters. One by u is minus 10. So minus into minus becomes 2 plus. Take in, don't convert into SI units please. For these problems all in CGS only you can take a result also will be in CGS system. This becomes equal to plus 1 by 20 plus 1 by 10, LCM 20. Result is 10 plus 20 is 1 by v, that is 30 by 20. V is equals to 20 by, sorry 1 minute, 1 plus 2, 3. If you take 200 you will get 10 plus 20, it is 20 you have taken LCM. So 21, 10 2s, which is equals to 3 by 20 is 1 by v. Careful with that, v again you have to take reverse, you will get 20 by 3, which is 6.666 you will get, 67 I can take centimeters is the image distance. You got it as a positive. Convex mirror compulsory v is supposed to be positive. Virtual, erected and diminished. Convex mirror always diminished. Image is virtual, erect, diminished. Always fixed. Next one is convex lens problem. Fifth problem. Concave lens. Concave lens means focal length compulsory negative. Diverging lens, it's also called as. This is the focal length. Focus you will get negative side, you will get f is negative. Concave lens, focal length is f is equals to 20 centimeters they mentioned. So concave lens focal length must be negative. F is compulsory negative. Convex lens focal length is always a positive, you have to take. Find the focal power. How much? You must convert this centimeters into meters. Compulsory for the power you need to convert it to meters. This is equals to 20 into 10 to the power of minus 2 meters. So focal power is nothing but equal to 1 by focal length mentioned in meters. That is nothing but equal to is equals to 1 by 20 minus of course into 10 to the power of minus 2. Power is equals to, take out the numerator, 100 by 20 negative sign, which is equal to minus 5 diopters. Or we can simply take the symbol as D. Next problems we will discuss next class.